Okay, so let us start the session. So today what we are going to see. So first session, we will be seeing about, let me show the details. So we'll understand why data warehouse. So I think already we have discussed it. We'll quickly see that. And OLAP, OLTP, and why data lake, and what is the purpose of cloud, and what is why we use Snowflake, ETL tools, what are the ETL tools, and we will understand how you can use Snowflake trial version, and we will go through Snowsite web UI, and we'll create a database table. So we will do a simple demo also. Like we will get into Snowsite, the web UI, and we will create a database. We'll create a table and load data from stage. So we'll do this at the end of the section. We will do that also. Okay. So first we'll understand. So why we need data warehouse, why we need Snowflake, and why we need ETL tools. We will understand that in detail. Then we will get into Snowflake fundamentals, all the sections. So other thing is, in the uh, course, if you have any questions, you can wait for the last 15 minutes, ask your questions, or if you want some relevant questions, you can put it in the chat. Okay, so that will help us to like continue on the focus on the session more, and then we will not interrupt the current part. So the problem is, like, sometimes they may not know a few things and they will ask it, so it will deviate from us from the topic. So that, to avoid that, you can put your question on the chat. So all the questions on the chat will be answered immediately if it is relevant to the session. If it is not relevant to the session, we will answer at the end of the session. So all your questions will be answered, but it will be answered by the end of the sessions. Okay. So let us start. Uh, so why Snowflake is very important for enterprise, and we have cloud. In cloud, we have different data warehouse tools. We have ETL systems. Why we need to learn Snowflake? So that we need to understand first. So for that, first let us understand what is data warehouse. Okay, so in organizations, in a bigger enterprise companies, they have different data sources. So, okay, so what is data sources? The data comes from different business groups. Okay, so for example, you have sales team, you have a marketing team, you have finance team, like that you have different teams in organizations. And that sales team can have different applications. They may use different applications. They may use ERP systems. They may use different enterprise products. And the data comes from that system. That is a one source for you. Like that, there are multiple source for organizations. So the data, you collect all the sources, and that data you store it in a centralized system so that you can use for different purposes. That is the purpose of data warehouse, where we are collecting data from different sources. That sources can be a database, it can be ERP systems, CRM, like flat files like JSON, CSV files. So you collect the data. So you can use ETL tools for doing that. So you can use different ETL tools for collecting this data, bringing it to the data warehouse. And in the warehouse layer, you can have raw data, you can transform the data, you can have different types of data in the warehouse layer. Okay, and the data here are going to be used for multiple purposes. So the data can be used again by sales team or purchase team or finance team, or it can be used by data science team. It can be used by different business users or business groups in the organizations. So for enterprise specific data, we store it in data warehouse. So we collect the data from various sources and we do consolidation. We reconcile the data. So because the data comes from different sources, there can be a duplication of data. There can be same kind of data coming from different source. So you have to do reconcile. You consolidate data and then you use it for analytics here. Okay, so this is what data warehouse is. Data warehouse can be in on-premises, can be in cloud. And in a cloud modern data warehouse systems, so we collect the data from various systems. So let us say in organizations, let us say retail organization or e-commerce company, where they have multiple departments. They have production team, they have warehouse team, they have finance, they have sales team or CRM team. They have websites, call center, different applications. From all these applications, the data comes into data warehouse. From that, we do analytics. Okay, so the data warehouse is a centralized place where you collect the data and then you do analytics here. So for analytics, initially, data warehouse was used only for analytics. From data warehouse, I can build a dashboard. I can do reporting. Okay, so I can take the data from like data warehouse. I can build a sales dashboard. I can build a customer based reports. So you can build dashboards and reports from your data warehouse. Okay, so that will be used by consumers. Who are the consumers here? Your top level business group, top level business management are the consumers who will use this dashboard and they can take decisions. They can help, they can see the high level informations about the ongoing activity and then they can take decisions. So for analytics, data warehouse plays an important role. Okay, so it provides you data informations. From that, you can build analytics, dashboards, you can build reporting. So data warehouse is used by analytical systems. Then why we are saying about modern data platform? So what is different than a data warehouse? So we already have a data warehouse which is collecting data from different sources and they are building analytics. Then what is modern data platform? Why we need to know about modern data platform? So in enterprise, so in enterprise, there can be multiple teams. Okay, so let us say we are collecting data from different sources. We are collecting data from like a MySQL database. Let us say MySQL database. I have SQL server. I have CSV data. I have JSON data. So how did this data came in? So this like databases, data sources, how did this data come in? So let us say I have a web application or a mobile application. Let us say I have a web application or mobile application. From that application, the data came into your database. So the data comes into your database. I have a ERP system or a SaaS product. Let us say I have a ERP or a SaaS. So from that, I am getting some data and the data is stored in SQL Server. Okay, we are storing the data in SQL Server. And I have some analyst who is extracting. I have analyst or I have some data engineers, cloud-based data engineers or data engineers who are extracting data from different systems. They are extracting data from another system, like a third-party system. External system, we'll say external systems. From external system, they are extracting CSV data or they are extracting JSON data. Okay, so we have different data. The data are coming from other systems. So it can be from web applications, it can be from ERP. So these are all data sources. Like this in organization, there can be 300 plus data sources. We may have 300 plus data sources. And the data can be stored in MySQL, can be stored in SQL Server, CSV data, JSON data. So this data, I have to store it some places. So I can store it in data lake. Because this data is larger in size or smaller in size, I'm storing into data lake. Okay, now this data has to be used by my teams. Like I have multiple teams. So I have a sales team who's building a dashboard. Who's building a dashboard. So that dashboard will be used by my CEO. So they are building a dashboard. And I have a marketing team. So the marketing team, they are building some reports. It's used by like different teams. It's like a business team. They are used by business teams. So they are working on like reports. So it's a reporting purpose. And I have a data science team who are building models, machine learning models. That models are used by different teams across the organization. That model is used by different applications. The applications are using this models. And I have a generative AI, like this generative AI applications, like which are used by bots or agents. So if you see here, the consumers here are different type of consumers. So I have business teams, I have application teams, I have bots. So the data, this data, they are going to use it. So they need this data. So I am collecting the data from different sources. I have to reconcile this data, bring it to a centralized place so these teams can use it. Okay, and this data is very raw form. So this data which is coming in from sources are in raw form. So I have to collect this data, do data quality checks, because the data is not in right quality. I need to do data quality checks, remove, do cleansing, cleaning of data, and then I need to transform so that this data can be used by this consumers. And I need to do governance here. So governance is again thing. That means I cannot give same data for all this team, right? So each team needs different type of data, different columns of this data. So you need to do better governance here. I have to create multiple tables. I need to give raw data. So for example, this data science team or generative AI team, they need raw form of data. They need cleaned data also. They need aggregated data also. Whereas this team needs aggregated data. Whereas this team needs raw form of data and I need aggregated data. So that is the problem here. The challenge here is the data coming from sources are used for different purposes. So why I have to create multiple pipelines? So why I have to create multiple data pipelines? So I can create one pipeline. So let us see. I'm creating a data pipeline. One pipeline for sales team, one data pipeline for data science team, one pipeline for marketing team. So if I'm going to create maintaining this like this, I've been creating a lot of pipeline. Maintenance of this activity is going to be heavier, and you are going to duplicate the data. Like and you are going to create a lot of consolidations and then reconciliations, like a lot of framework for this. So this becomes a maintenance activity, a lot of work for data engineering team, a lot of work for analytical teams. So this is a problem with organizations. They have different business group and they have a lot of sources. Creating like this kind of workflow creates a problem. So they have to centralize this. If they can optimize this, they can try to generalize this and build workflows. So they can build a layers. They can build a layers and centralize this process. So that is done in the data platform. So in organization, they have a data platform. So data platform, they centralize this. So they build a layers. So in the layer, they store it into centralized storage layer that can be data warehouse or data lake. And the consumers here can be different kind of consumers, analytical systems, intelligent systems, machine learning, generative AI, like different kind of systems. And the data you collected here from the sources can be different type of sources. So this consumers doesn't have to have an individual workflow. Okay, they don't need to have an individual workflow. Instead of that, instead of that, they can read from the storage layer. The data is already there in the storage layer, and your the framework data platform, they are building a generalized framework that helps to bring the data into your storage layer, and from the storage layer, the consumers can use it. So we are avoiding the duplication of work. We are doing the generalized platform layer, which helps us to solve this problem. So in organizations, they have a data platform which is going to help you to solve the repetitive problems, to help you to bring the data into storage layer and can be used by multiple consumers. So we are trying to solve the problem of multiple consumers here. As I have multiple consumers and they are using for different purposes, I am bringing into centralized layer and I have the same data in different forms. The same data I have it in raw table, I have in a process table, I have in aggregated tables. So the consumers can use the data. So that is the advantage here. So the data which is coming in here, this data, I can store it in raw form, processed form or aggregated. So why we do need to do this? Because my dashboard, it shows aggregated data. So the dashboard shows aggregated data. So for the dashboard, we need aggregated data. For marketing team, again, we need aggregated data. Okay, but data science team, they need raw data, they need process data, and then they need aggregated data. Okay, so they need all kind of data. And even for generative AI, they need process data, they need aggregated data. Okay, so different teams need the same data in different form. So in our storage system, we store the same data in different forms. So we may have to maintain in raw form also. We may have to maintain in aggregated form also, in the process form also. So we call this different names. We name it as bronze, silver, gold. So we name it as bronze, silver, gold. Okay, so this data, the raw data can be in data lake, can be in data warehouse. Why? Why same data can be in data lake or data warehouse? It's based on the scenario, based on our requirement, like based on the data type. So if the data is in CSV form or JSON form, it's a very raw form. I don't have to store it into data warehouse. I can store it in data lake, then move it into process data. I can move it into Snowflake or data warehouse system. Okay, so we combine the storage system can be any of this. It can be data lake or data warehouse. So we will see why we are using data lake for some scenario. We will see why data warehouse for some scenario. We'll see that later. So here in a data platform, we do analytics, we do big data processing, we will do ETL, we are going to do transformations. So we have different frameworks. It's not that it's one framework we are going to solve, right? So it uses different components here. So for like you can see the layers here, sources, data sources, ingestion layer, storage layer, cataloging, processing, and consumption layer. So it's not one product, it's not a one tool for solving all this thing. So in organization, they use multiple tools for this. And in cloud, there are a lot of tools. There are a lot of tools, open source tools, or the companies buy some products, SaaS product and use it. Okay, so that is how a modern data platform is built. It's not a one platform, it's a collection of multiple tools and framework. So in ingestion layer, we may use ETL tools. That ETL tools can be open source tools, or can be a AWS or Azure cloud tools, or it can be a Snowflake tool also. So Snowflake also has ETL tools. You can use that for batch processing or streaming in ingestion. Like that, for storage layer, this storage layer can be data lake or it can be data warehouse. So this data warehouse can be like a Snowflake, can be Redshift, or it can be Google BigQuery. Or so it's about organization, right? About the licensing, how how they are, how their budget is. Can they buy a data warehouse system, or they are going into cloud purchasing that? It's based on that and based on the requirement. So they are going to choose. We will see that why they choose all the systems. We'll see that, and they use data lake and they use data processing. The processing layer is a transformation layer. So this is the transformation layer. In transformation layer, you can use SQL, you can use DBT, you can do use Snowspark here. You can use Python here for big data processing. So you can, in the transformation layer, you can use different systems. Okay. So far we have seen discussing about big data, data platforms, modern data platforms, and who are the consumers. So why we are getting into modern data platform? Previously, like we say that like 10 years back, companies were into analytics only. Okay, so they don't need modern data platform. But in the current architecture, in the current scenario, they have analytics, they have machine learning, they have generative AI applications. Like that, they have a lot of requirements. In the modern world, we have data products, we have data driven applications, we have data driven, lot of solutions are built. So for that, the consumption layer is keep on increasing. So we want to have a data platform where we bring the data and store it into different forms in the storage layer, and that can be used by consumption layers. Okay, that is the purpose of building a modern data platform. So the data platform you can build using different systems. So let us see that. So data platform in organizations are can be built on different cloud, can be built on different framework. Okay, so for example, let us say I'm in AWS cloud or Azure cloud. So they are the most used in the organizations. So I can, if my company is using AWS cloud, I can build my entire data platform using AWS cloud or Azure cloud here. So why cloud here? So we need to know what is the purpose of cloud, why we need cloud. So let us see that first, then we will come to this. Okay, so AWS cloud, or let us say Azure cloud. So why company has to go for cloud? So in organizations, they need different kind of resources. They need virtual machines, they need Linux machines, Windows machines. They need computation layers. They need networks. They need database. So like that, they need different systems. So for applications, that application can be web application or analytical application or data-driven applications. So for building any applications, they need resources. That resources, they get it in cloud. So instead of maintaining your on-premises, instead of maintaining your infrastructure, cloud providers helps you quickly create your resources and then use your resources in a quick way. It's highly easier to create, so that we call it as provisioning. Provisioning is nothing but creating resources. So if I want database, I can create database in cloud. So if I want VMs, virtual machines, I can create virtual machines in the cloud. So if you want to store large amount of data, so let us say I have a lot of data, I want to do analytics from the data. So I have to store this data because the data is in semi-structured form, or the data is in very raw form. So I cannot store it into database. So I'm storing the data into flat files, or the data is in unstructured form. The data is in video form, or audio form, I want to store the data. So I can go to cloud, I can store it into data lake. So in cloud, your data lake is cheaper where you can store large amount of data. So the enterprise for infrastructure maintenance, which is very complex for them to maintain, they are going into cloud provider, and in cloud you can easily provision. It's highly scalable and it's cheaper, and you can easily manage the expense. You can see from the browser, you can manage the expense. It is easier to access for teams, easier to access. Now let me go. So I'll go to a browser. I will open AWS Cloud. So if you have browser, you can start using cloud. So I'll go to AWS Management Console. So you can see here, I'm logging into cloud. So if you don't have AWS account or Azure account, you can create a free tier account. Okay, so you can go to AWS free tier. So 6 months of free, they provide you free tier account where you get some credits by free. So you can use lot of free services for free. So in the course, we are going to use S3. We are going to use few of the service. So that most of the thing will be part of free tier. Okay, so you can use that. So if you don't have account, you can create a free tier account. So for that, you need to give your email ID, and it may ask your bank credit cards or debit cards for creating this account. So it's a pay and you like it's like use and pay. So that means you are using it. After 1 month, you are going to pay. They are not going to charge you anything initially. They may charge you $1, but they will refund you that dollar. But after 1 month only, you are going to pay for the usage. That means you have used for 1 month. After that, I'm going to pay. So your cloud provider, they charge you monthly wise, and you are going to pay at the end of the month. So you can create your free tier account. So I already have account. So I'm going into my account. So using email or phone number, I can log in. So I'll log in with my email ID. So I'll click on sign in with user account. So I'll give my email ID. So I have to give my password, and then I have to sign up with the OTP. So let me do that quickly. So if you already have AWS account, you can use your account, or if you don't have any account, you can create your account. Okay, so because when you are going to work with Snowflake, we are going to use the data from your AWS account also. The data will be there in stage. We are going to use our cloud as a stage environment. So let me give the OTP. Okay, so it's taking time. Let me give it. So if you are already having Azure account, you can use Azure account also. So Azure, let me log into Azure account also. I'm using portal.azure.com. So why AWS? We are starting with AWS because when you are learning Snowflake, Snowflake first initially, they started their integration with cloud with AWS. That is why we are going to focus more on AWS and then little bit on Azure. Okay, so our focus will be more on AWS because AWS and Snowflake works together. And from initial release, Snowflake is supporting AWS. So they have a lot of integration with AWS. Okay. So it's logged in. So here I've logged into my AWS account. You can see the services here. So AWS provides a lot of service. They provide, you can create storage. You can create storage as a service. So if I want data lake, I can go to S3. I can go to S3 and I can create a buckets. So I can create buckets and put my data here. So I can store any kind of data. I can store CSV, JSON, jar files, audio files, video files in the data lake here. So if I need a database, let us say I need database, relational database, I can go to database services like RDS. In the cloud, I can create a database like MySQL, Oracle, SQL Server, Postgres. So I can create database in the cloud, and if you see, I can use it for production. So this environment, I select MySQL, I can use it for production. So they provide a multi-AZ cluster deployment zone. That means a highly available environment. So I can use it for production. So like your cloud providers helps organization to quickly bring your resources and help you to productionize faster. So that is why cloud become very popular in the last like 8 years. If you see, cloud is very popular because it's quicker for companies to create resources and start building applications. So they can work on their core application, then managing the infrastructure. So cloud providers tells you, you don't have to manage the infrastructure. We will provide you the infrastructure. You can build the application on top. So I can create my database. I can build my data lake. So I have other service. I can build compute. If I want Linux machine, I can go to compute. So I can create Linux machines, Ubuntu or Mac or any type of OS. I can quickly create it. Okay, so I can create one machine or 10 machines here. So like quickly, I can provision, I can create like 10 machines. Okay, in cloud. So as I said, it provides you resources. So for that resources can be specific to storage or database related, or it can be like web applications, mobile application, machine learning, analytical systems. So it provides you for different services. They provide you services. Okay, you are not going to use all the services in enterprise. We use few of the services. They provide. There are 200 plus services here, but we use like like 10 or 20 resources in organizations. Okay, so if I can create RDBMS, I can create NoSQL database, I can create machine learning applications, I can work on analytical systems here. So the cloud provider provides you different services to build your applications on the cloud. Okay, so on top of cloud, you can build your applications and and you are going to pay monthly your expenses. So I can go to my cost explorer. I can see what are the resources I used and pay for that. So you can see here monthly, it shows you what are the resources I used and how much I have to pay. I can see it monthly. So if I see that last 7 days, what are the resources I used? So I can see how much I have used. So I used these resources. I used S3, I used Glue, I used Bedrock. So I used all these services in last few days. So in cloud, I can easily measure it, how much I'm using, what are the services I'm using. So here in the cloud, I can create account. I can add multiple users. There is a service called IM where I can go to users, add all my users, or I can create a group and add my business groups here and provide them access. So in cloud, so in organizations, they have their own account. They add all the users and based on the user's requirement, they use the services. Okay, that is how cloud account is used. Okay, so cloud is cheaper and it's easier to use. So you in your enterprise, you can build a data platform using cloud services. Okay, I can build this modern data platform using AWS or using Azure. Okay, so you can see here, I am building the modern data platform using AWS. Here you can see I have data sources, I have ingestion, I have transformation layer, I have data serving and consumption layer. So I have different layers. So I'm using different AWS service and then doing it. But what is the problem here? So if I'm using here, so if I'm using this layer, what is the problem here? So even though AWS provides you a lot of services or Azure provides you, so if you see the same data platform, I can build it in AWS, I can build it in Azure, so and my teams can use it. So the data platform, which is like connecting to your source, extracting data, transforming the data, and serving the data. So this layer, you can build it using multiple architecture, but each has their own advantage and disadvantage. So by selecting this component, by selecting this framework, you have advantage and disadvantage. There are multiple frameworks, but each has their own advantage and disadvantage. So you need to understand that. So by using this framework, what is the best way? So in enterprise, what is the best approach they use it? When you are designing a system, when you are architecting a system, what are the components you choose, which gives you better performance, and where you need to see which gives you good, cheaper cost and higher performance, and which gives you a better efficiency in building your data platform. Okay, so when you are designing a data platform, you need to choose all these components efficiently, so that your cost is cheaper, your performance is faster, and you are able to store large volume of data, and you are able to scale the applications, and you use it for multiple purpose. Okay, the requirement we have is, I am going to use it for multiple purposes, I'm going to store multiple data, and I need to have a cheaper cost. So that is the requirement we have. So if you see here, I can build a data platform using AWS services or Azure services. Then why we need Snowflake? So here, if you see in this architecture, only for data serving, we use Snowflake. That means we store it into data warehouse. We use Snowflake as a data warehouse, not in the transformation layer, but only in the serving layer. So what is the advantage here? What is the disadvantage here? Okay, so let us see that. So we need to know this, because when you are going for interview, they may ask you all these questions. So why you are using Snowflake as a data warehouse? Why you are using transformation layers? Why we are using ingestion layers? They may ask all these questions. So we need to know all these answers. So you are going to interact with different source systems. You are going to work with different source systems. For ingestion of data, we call it as ingestion. Ingestion is connecting to the source, extracting the data. For ingestion, you can use cloud tools like AWS tools or Azure tools. You can use it for ingestion. But for transformations, you cannot use these tools, because the data is there in Snowflake. If the data is there in Snowflake, you have to run your SQL, you have to build your transformation layer using Snowflake. That will give you a better performance. That will give you better uh, usage of your data than having a separate layer. Okay, so that is the advantage. So you can use here for transformation also. If we use Snowflake, you are going to have a lot of advantage here. So you're not only on data serving, for transformation layer also, we are going to use Snowflake. Okay, so it's possible that you can use the other tools for building it, but you are going to have slower performance. There are a lot of advantage and disadvantage. We will discuss one by one later. Okay. Okay. So in a data platform, you see we have ingestion layer. We have storage layer, we have processing layer. So ingestion layer, as I said before, I can use different tools. I can use DMS, I can use glue, I can use different ATL tools. I can use different ETL tools, or I can go with Snowflake. I can use Snowflake for ingestion also. Okay, so I can use Snowflake for doing ingestion, and for transformations. So in the transformation or the consumption layer, you can use different tools. So let us compare. Okay, you can see now when we are using Snowflake, what are the ingestion tools we use? What are the transformation tools we use? Okay, so we will see that. So ingestion tools, you can use ADF if you are using Azure. If you are going to Azure Cloud, you can use ADF. If you are using AWS, you can use Glue. Glue is a popular ETL tool for doing ingestion. Okay, other than that, if you're using Azure, you can go for Synapse Analytics. And there are like SaaS-based ingestion tools like Phytron, Stitch, Airbyte. Okay, so for ingestion of data, you can use any of these tools. So what is ingestion? So if you see the ingestion process, it's collecting the data from sources and bringing it into your storage layer. Okay, that is the ingestion process. So you need to know all these terms, right? So you need to be comfortable on all this terms: ingestion, storage layers, cataloging, processing. All these layers you should know because you are going to work on all these layers. So when you are going for attending interviews, they are going to ask you questions. In ingestion layers, what tool you used, or in storage layer, what tools you used, or why did you use in storage layer, why did you use data link? So again, they are going to ask you these questions. In ingestion layer, did you use batch processing or did you use streaming? So what kind of framework use they're going to ask you. So you should able to answer all this thing. So that is why we are discussing about the architecture. We are discussing high level about the architecture and the platform here. So we are starting from the high level scenarios here. If you understand the high level architecture, it will become easier for you to understand the in-depth individual sections here. So even though in organizations, you may be working on ingestion layer, or you may be working on the data transformation layers or processing layer, but you need to know the high level architecture, high level, the data platform. So that will give you easier understanding of the entire applications or the entire thing what you are going to do. Okay, that is why we are learning on the architecture. Okay, so in a data platform, I can use Snowflake as a data warehouse. Okay, I can use Snowflake as a data warehouse only for storage. Or I can use Snowflake in data warehouse in the storage layer also. I can use it in the processing transformation layer also. Okay, I can design my architecture in different ways. So what are the benefits we get? So by using Snowflake as in the transformation layer, I will get a better performance. Okay, so advantage is I'll get a better performance. My SQL queries are going to be faster because I'm running directly on the Snowflake. So if I'm going to use, let us come to the scenario here. So I have AWS Cloud, I have Azure Cloud. In AWS Cloud, I have ETL tools like Glue. Let us say Glue. Here I have, for ETL, I use ADF. So let me make it easier. And SaaS product, let us say Phytron or Airbyte. We are going to use Airbyte here. So for ingestion, for the ingestion process, I am using a ETL tools here. So my source here, let us say my source is a MySQL system. So I'm going to collect the data from MySQL, and I can do it in any of these tools. I can use Glue, So I'm going to connect from MySQL. For that, I use ETL tools. I can use Glue and collect the data. I can use ADF and collect the data, or I can use Python or Airbyte and collect the data. So all these things are ingestion tools. So other than this, I can use Python or I can use Java or any programming language, right? From that I can connect to Snowflake directly, extract from MySQL and write it to Snowflake using this. So this we call it as custom applications. So companies can build their own custom applications. Okay. So here they are using Python or Java. They are reading the data from MySQL and writing to Snowflake. So you can use this ingestion tools or you can use custom applications here. So what is the advantage here? So this tools supports. So for example, Airbyte supports or Fivetron supports 400 plus data sources. Okay, it supports 400 plus data sources. Glue supports 100 data sources. ADF supports 200 data sources. So company, if they can build this custom application for one data source. But what about this? If they are using like 100 data sources, what about 100 data sources? They cannot keep building like this custom application for 100 sources, right? Maintaining this application code will become complex for them. That is why they go for ETL tools. Okay, so if there is only one data source, they can maintain it. But if they have 100 plus data sources, if the data are going to come from 100 sources, then it becomes difficult. Okay, it become difficult. They have to go for ETL tools. So I'll go to Glue. So I'll go to AWS and I'll go to Glue here. ETL jobs, Visual ETL. So you can see the sources here. So you can see how many sources they support, right? So they support, like you can see MySQL, Postgres. My source here, target here. That means I can extract the data from source and write it to target. So my target can be Snowflake. My source can be any of the system. Okay, it can be RDBMS, it can be NoSQL, it can be like products, right? You can see a lot of products. They support a lot of products here. So they support 100 plus sources here. Okay, so if it was one source and one target, companies can easily build an application like custom application, but they have 100 sources and this ETL tools helps you for easier doing it. Okay, so easy doing it. Let us say take about Airbyte. Let us go to Airbyte. So I'm running Airbyte in my local. So Airbyte is down. I'll start it. Okay, meanwhile, if it is starting, I'll go to ADF. So I'm opening ADF. So we are comparing different tools, right? We are not started so far. We are just discussing about various ETL tools. So I'm comparing for ingestion process. What are the tools you can use and what are the advantage each tool has, right? That is what we are discussing. So in ADF, you can see linked. So you can see here, they support 200 plus sources here. They support database. So using ADF, I can connect to different database. Okay, and I can write it to Snowflake here. So I can use ADF. I can have connect to different sources. I can extract the data and write it to Snowflake. Okay, so you can see here, you can connect to SAP, can connect to MySQL, Postgres, BigQuery, different database, Azure specific services, like different. So you can see different products, SaaS products like Salesforce, Shopify, like different products here. No SQL database. Okay, so like they support 100 plus again data sources here. So in ADF or Glue, you have easier option from UI. I can go and create connections. So you create connections from UI. So this tools help you UI based option. So I can use UI for creating connections. So I can create connections and then extract the data and write it to your target systems here. Target can be your Snowflake here. So companies can build their own custom applications or they can go for ETL tools. Okay, so if this is for ingestion of data. So that means I have different data. My data is there in different systems. I have to collect the data, bring it into Snowflake. Then only the transformation is the next part, right? So you have to bring the data into Snowflake. For that, we are using these tools. So that is what we have seen so far. So I'm logging into Airbyte. Airbyte is open source. It's again a product. It's not specific to one cloud. You can download and use it in local. So you can see in the Airbyte, I can go to source. I can click on new source. You can see how many applications they support. They support like they have support like a 300 plus data sources. Okay, so you can connect to Salesforce, like Stripe. Okay, so they have connection to multiple sources here, and destination can be your Snowflake. Okay, they can extract data from different sources and they can bring it to Snowflake. So for ingestion, you can use any of these tools. Okay, so why these tools? These are easier for organizations because they have a lot of data in multiple places. They can use these tools and collect the data, bring it to your Snowflake. So these tools are easier for organization to use. Instead of writing custom code, they are like using these tools. So you by using UI, you can create connections. You can give the server names, username, password, and extract the data and bring it to your data storage layer here. So you can see ingestion layer, you can use any of these tools. Okay, you can use any of these tools. So in our course, we are going to use Glue, we are going to use ADF, and we are going to use Airbyte here. We are going to use Airbyte for ingestion. So you don't have to learn all this thing, right? You don't have to learn all the ingestion tools. You can learn one of this. You can learn either Glue or Airbyte or ADF here for ingestion. So that you use one tool. If you learn one tool, it's easier to learn other tools because everything are similar. Okay, you can see here when to use cloud ETL tools. So why we go for cloud ETL tools? Okay, so even though companies can write their own custom logic or they can use Snowflake, In Snowflake also, you can do ETL. Okay, Snowflake has ETL capabilities where you can connect to source, extract data. But why we need to go for cloud tools? So if you have different sources, like I have APIs, I have on-premises systems, I have ERP systems, like that I have multiple sources. So in that scenario, your ETL tools provides you easier way of connecting and extracting data. So that is the advantage here. So it reduces the Snowflake, the core purpose of Snowflake, it's on the data layer, right? So it's for transformations, running your SQL. So that is where you have to spend a lot of time on using Snowflake, not on the extraction of data. For extraction of data, you can use these tools. So here, they already provide you wide connections and easier way of extracting data. So you can use these tools where you can using UI options, or you don't have to do transformations. You are going to extract data. Okay, for that you are going to use these tools. You can use Snowflake ETL tools also for some scenarios. Okay, so I can use ETL tools provided by Snowflake also for some scenarios where I don't want to, I have connection details, my data is there already there in the data lake. So at that time you can use Snowflake ETL tools. Okay. Okay. So far we were discussing about various tools you can use it in the ingestion layer. Now let us go into Snowflake. So Snowflake, I already have. So I already have this Snowflake trial version. So how you can install Snowflake trial version? So let us see that, and we will see how to get started on Snowflake. Okay, so that is what we'll see for now. So you can go to Snowflake website and sign up for free. Okay, so you can sign up for free trial account. You will get 30 days free trial. Okay, and here you can use your email ID, and when signing up, it will ask you to choose the cloud provider here. It will ask you to choose AWS, Azure, and which region you want to select. And you can choose here enterprise, not the standard one. Choose for enterprise future and choose here AWS. Okay, so and region, go for US region, like US West region, because that has the latest future. If you're choosing Asia, it will not have all the latest features. So in Snowflake, the latest features are available only in the US regions. Okay, so when you are going to choose the trial version, in the next step after filling this, you have to choose this one. You have to choose what version of Snowflake you are going to use. So Snowflake has different editions. Like they have standard, enterprise, and business critical. Okay, so in standard versions, which has limited features. In enterprise version, you have a lot of features like time travel, multi-cluster warehouse, materialized view. So you have multiple like features here. And business critical has enterprise feature. So for us to verify, you can use enterprise version here. You can choose enterprise version, and you can choose AWS here, cloud provider AWS, and you can choose here region US West. So after doing this step, you will get your email, and you can go and click on that email and validate it. Then you will get, you will get an email like this. You can click here to validate. The next step is you will get your email in the email you will get the URL. Okay, so you will get the Snowflake URL. Using that you can log in. Okay, like this you will get the URL. Using that you can log in. So once you log in, so you can see the Snowflake web UI here. This we call it a snow site. Okay, so the snow site is a web UI. So if you see here, Snowflake, if you see Snowflake, For running Snowflake, you don't need to do installation because it's a SaaS product. It's running on the cloud. It's running. Snowflake cannot be run on premises. Snowflake runs on the cloud. So if you go and see here, my account, it's running on AWS. You can see it's running on AWS. I can see the account details here. So the server here, this server is running on AWS. So which region it is running? In AWS, it's running on US East. Okay. So your Snowflake runs on top of cloud. It uses the cloud for storage, uses the cloud for VM. Okay, so Snowflake is a cloud-based data warehouse. It's built on top of cloud. So you cannot use Snowflake on premises. You can use it only on the cloud. So that is why we have seen what is cloud, why we need cloud, all this thing. So because your Snowflake is running on top of cloud, and Snowflake uses a AWS account or Azure account for running. And if you see here, I am using Snowflake and it's running on top of AWS account here. So if you have chosen while installation, while going for the trial account, if you have chosen Azure here or AWS, like AWS or Google Cloud here, based on the what you select, you will see it here. Okay, your account will be installed on top of the cloud. So if you choose the AWS, integration with AWS service will become easier. Integration with your AWS service will be easier. If you have chosen Azure, integration with Azure will become easier. Okay. If you have chosen here Azure, and if you try to do integration with AWS, then you will have a lot of challenges. Okay. That is why while choosing the trial account itself, choose AWS, because we are going to see a lot of integration with AWS. Okay. So this is how you choose your trial account. So once you create your trial account, a Snowflake trial account, you can use it for 30 days. So I can see all my database here. Initially, when you log in, you are going to see some default database. So you can see my account. I don't have database here. I have sample data. So I can see this sample data is provided by Snowflake for you to practice. Okay, so this database is a core database where it is used by Snowflake product itself. So we are not going to touch this. This sample data, you can use this for running some queries, for doing some performance testing, for doing some query analysis. We can use this sample data. Okay, so this you will have by default in your account. Once your trial account is created, you can see the sample database. And in the sample database, this is a benchmark data. TPC is a benchmark data. If you go to the stable detail, you can see here the data. So I can see here how much is the data size here. So this data is 150K and 10.3 MB of data. So I can see the data. I can preview the data here. So I can preview the data. I can see the column details, and what is the size of the data and how much records are there. I can see it here. So here I'm going to orders. So orders table. It's 1.5 million and 40 MB of data. The size is 40 MB. So this is the biggest table here in this TPCH SF1. Okay, so this is a database name. So the database name is this one. Snowflake sample data is a database name. Within database, you have schema. Within that, you have tables. So here we have 3 level of namespacing. Okay, so in Snowflake, you are going to have 3 level of namespacing. You have top level database. Within database, you have schema. Within schema, you have tables. Okay, so if I create a new database, let me do it. So I can go to Snowflake. I can go to create plus I can create worksheets. I can create Python worksheets. I can create tables, stage, like that. I can create multiple things here. I'll go to database. So I don't have option to create database from UI. So I'll open a SQL worksheet. I'll create a new worksheet. So I'm creating a new worksheet and I can write code here. Okay, so in the worksheet, I can write code. I'll say create database demo. So I'm creating a new database. So this is the editor where you can write SQL. So I'm writing SQL here, create database demo. So my database got created. I can verify, I can open a new tab. And I can go to database and see demo got created. So I created a new database. By default, you have schema, public schema. Okay, you can see public schema, but I don't want to use public schema. I'll create my own schema. Create schema. So I'm creating a database. I'm creating schema. So now you can see I created my own schema. So we have two level of namespacing, database. So this is the database. Inside database, I can create schema. So I can create from UI also. I can create a schema from UI. I will say this. So in Snowflake, we have three level of namespacing, database, schema, and then within schema, you are going to have tables. So inside schema, I can create my tables. So I can go here, click on tables. So for example, I want to create table by using file. So I can go here, I can click on the create table from file and browse for the file from my local. So I have a CSV file. So I have a CSV file, sales data. So that data I want to create as a table. So I'm doing it everything from UI. So I'm creating a new table. So it's a CSV file. So you can see automatically it has chosen the data type. From the data, it has chosen the data type. And in the CSV file, I had the headers. Okay, I had the headers. Let me open the CSV file. So this is the CSV file. If you can see in the CSV file, it's 1000 records. And at the top, first line, I have headers. So your Snowflake automatically detected the column names by using the header here, the first column. So I'll say load. Okay, you can see here, I can see the data. So my 1000 records got loaded. I can query the data. So I can see the table. I can see now, if I refresh it. So in the raw schema, we uploaded a CSV file using UI. I used this UI option, create table from file, and created this table. So I wrote it like 1000 records. I can see the data. Okay, so from UI, you can upload a file, upload data. So I can see the way I can run SQL on the data, on the CSV file data. Okay, so you can see how quickly we were able to extract data from CSV and convert into table, and I am able to run SQL on top of that. So using Snowflake from UI, we did all this. So we created first database, we created schema, and using UI options, we were able to load data and see the data from the Snowflake. Okay, so in Snowflake, from UI, you have a lot of options to do. So we are going to see some options from UI and a lot of options from SQL. Okay, so from when you are going to do some complex operations, we will use SQL. or in real time, we will not do it from UI. Why we will not do from UI? Because I have multiple environments. So I have in my organizations, I have environments like dev, QA, stage, and prod. So four environments. So we are going to have four environments. So I write, so I can create tables. I can create a database. So I'll say that. So I'm going to create database. I'm going to create schema, tables, views, or store procedure. So if you see all the tables, view, store procedure are object of schema. Okay, so if you go to the schema here, I'll go to raw schema or demo schema here. You can see here, I can create tables, I can create views. So all this thing are the objects, Snowflake objects of your schema. So if you see the like all this tables, views, procedures, streams, tasks, functions, all this thing are objects of your schema. So I can create all these objects from UI. If I create it from UI in dev, I cannot do it in other environments because this environment I'm not going to have access. This environment only DevOps may have access. So you have to create this using scripts. Using SQL, you have to create everything using SQL. So if I create using SQL, then I can take this deployment scripts. So I'll say this deployment script. So I can take the script, run it on QA, run it on stage, run it on prod. So this is how we do it in real world. We don't do it from you. So that is why you need to learn SQL, using SQL, how to create all the resources. And you have to have the deployment SQL files, deployment scripts, so that you can deploy it in other higher environments. So here this, even though you will not have access to this environment, DevOps will run this one. So DevOps is going to run this. They will have access. So in enterprise, we have a complaints who developer cannot have access to higher environments. The higher environments, normally another person will do the deployment. So DevOps will do deployment using your SQL file. You will provide the SQL file and you will give the instructions to this DevOps. So they will do the deployment on the higher environment. So when in real world, we are not going to do it from UI, but you can use UI for learning purpose. For learning purpose, you can do it from UI, but we will use SQL and do all the development. Okay. So far, like we created a data. So we created a CSV data, a table, and we are able to read the data. Okay. What about if I have like a 10 million of data? So let us say I have 10 million of data and data is there in S3. Okay. So the data is loaded into S3. So I have a bucket. Let us say I have a bucket. So data is loaded into S3 by an external team. So in organization, we have multiple teams. So that like other teams are loading the data, they are bringing it to S3. And you are going to read the data and load the data into your Snowflake. Okay, so you are going to work on that. So for that, we create a stage. So we create a stage. So if you go to Snowflake, you can see here. Create stage. So I can create external stages. I can create AWS S3 stage, Azure stage, or Google Cloud stage. So if you choose here S3, you have to provide your stage name. So stage is nothing but staging area. So that means the files are going to be placed in this area. You are going to take that file and process it. Okay, so I can give a name here. I can give the URL of the path and what type of authentication mechanism I want. So I can use integration mechanism or what type of mechanism I want. So I can take the data from S3 and use it within my Snowflake. Okay, the purpose here is like I have external team. They are sending me the data, and that data is sent to Snowflake into your data lake. You have to take the data and process it. Okay, so you create a stage layer. So let me quickly do it. So using command, so I'm creating a stage. So if you see this command, so I'm creating a stage. So I'm saying create or replace stage. This is a stage name. And I'm creating the stage on this database, on the schema. And this is my URL. I want to access this bucket. In S3, I have a bucket. I want to access that particular bucket and credentials for this. So I'll explain how we can create these credentials. What are this in the next sessions. For now, I'm giving some credentials and creating a stage. You can see the stage now. Now if I refresh it, I can access the AWS data. Okay, you can see how quickly I was able to access my AWS data. So I can now use the stage name. I can start accessing my data. Okay, for example, there is no data here. Okay, you can see here. So I'm able to see my AWS account. In my AWS account, in a folder, I have a CSV file. I can access the AWS account. So if you see here, my Snowflake is running on a AWS account. So it's using a AWS account. This AWS account is provided by AWS. It's provided by Snowflake. Okay, this is a different account, and this account is my account. Okay, so I have data in this account. So if you see here, I am using a Snowflake trial version. So I have a Snowflake. Snowflake is running on a AWS. So this account, so this is the account name is, this is the account name, and it's running on US East one. This is the account name, and it's running on US East. On a different region, East one. So this account is a AWS account. This account, it comes with my trial version. Okay, so this AWS account, so this AWS account, it comes with my trial account. So I have another AWS account. So that account, we go to AWS, you can see this account ID. This is a different AWS account. Let me go to accounts. I'll get the account name. So this is my account ID. Okay, you can see this AWS account. I have S3 buckets. I have data here. So for the Snowflake account, this account is an external account. So this is an external account. So I am able to extract this data and use this data. Okay, I'm able to quickly create a connection, create a stage, and from the external account, I'm able to access the data. Okay, like this, see if I can have multiple AWS accounts. So let us say instead of AWS, I have Azure account. So I have Azure, another account. I have data here. So from Snowflake, you can access AWS data also. I can access my Azure account data also. Okay, by using stage. So by creating stage, the external account data, you can easily access it. So that is the advantage here. So if your teams are working and they are putting the data here, they are putting it to AWS or Azure, you can create a stage. So I can create a stage here. I can name this AWS stage 1. Azure stage 1. So I created two stage, and this stage becomes local to my Snowflake. Okay, so it becomes local to my Snowflake. I can access this data within Snowflake easily. So the advantage is you mounted your AWS data lake inside Snowflake. So you can use the data inside your Snowflake. So that is the advantage of creating stage and using within your Snowflake. So this helps organization to easily use the data. So easily use the data from different buckets, different account, and use it for various purposes. So we will see this in detail, how this integration works, how you can give password, all this thing. For now, I am shown a demo. Okay. So for us to practice, Snowflake has provided you some sample data. Okay, I can create a stage. So our database is demo. So this URL, you can see this URL. It's again a S3 URL. This is provided by Snowflake. Sample data provided by Snowflake. So it's nothing but Snowflake quick starts. So this data, you can use it for developing faster. Okay, so I'll use the schema. So we created a stage. So we created a stage. Now if I go to this stage, so I can see some data here. Okay, so I can see some 6 GB of data, 7 MB of data. I can see POS data, customer data. So this environment, this, you have two stages here. You can see two stage. This is my S3 bucket, and this is provided by Snowflake. This bucket is provided by Snowflake, which has some sample data. So I'm going to take this. I'm going to create a new table. So you can see I'm creating a new table. I'll use demo, my database name, demo underscore schema, and this is the table name. And we are mentioning column names here. So I'm quickly creating a table. So you can see I'm creating column, number, varchar, different columns. I'm creating this table. And I'm going to copy data. So this is demo. Okay, you can see here. So I'm going to use this data. I'm copying into table. You can see here what we did. Quickly, I'm showing you how can I extract data from another data lake. So what we did, we have the sample data provided by Snowflake. So the sample data, which is a tasty byte data. You can see tasty byte data. We go to menu. So you can see this menu. So this CSV data we loaded into Snowflake table using copy command. Okay, using this command, we loaded. So you can see how quickly I was able to extract data, bring it into Snowflake from your S3 bucket. Okay, so if you bring the data into S3 bucket, it's easier to load it into Snowflake. So that is the advantage. Okay, so Snowflake internally uses your like a cloud account. Okay, so Snowflake uses a cloud account. So it stores the data into cloud. So Snowflake, if you see the architecture of Snowflake, which we will discuss detailing in the next class. So in the Snowflake architecture, it has three layers. It has storage, it has compute. So let me quickly show that. So if you see the architecture of Snowflake, it has storage, compute, and service layer. Storage account is tied up to your cloud buckets here. So the cloud storage is nothing but your bucket. Okay, Snowflake uses cloud like buckets for storing the data. Okay, and like compute layer, they use VMs of cloud, and this is again Snowflake layers. So for example, if I go here, Snowflake is using this AWS account. All the data, whatever we did here, the data are stored in the bucket. Okay, so the data are stored in the bucket in this account. In this account, the data is stored in the bucket. As a Parquet or some format, as a column store format, it's stored. That is how Snowflake is using cloud for storing. Snowflake is using the cloud's VM, virtual machines for computation. So your Snowflake is using different layers provided by cloud. So Snowflake is a data warehouse. It's a cloud-based data warehouse. Why we say cloud-based data warehouse? Because it's using all the cloud resources for storing, for doing computation, and it's integrating with all your cloud to do all the data warehouse functionality. That is why we say it's a cloud-based data warehouse. Okay. So now you can ask all your questions. So far we have seen like what is data warehouse, what is data platform, so why we need data platform? So how you can build data platforms using AWS, using Azure. We have seen all this thing. And then we started into Snowflake. We have seen why we need Snowflake. And in Snowflake, we went into trial account and we created a database and we created a tables. So we have seen simple demo on Snowflake, how to create tables in Snowflake. So I used UI. First I showed with UI, I created a data. Then I used a data lake. I extracted the data from data lake and created a table data. So if you see the data here, you can see we have two tables. One is menu. This data is from, the data is from S3. This data is loaded from S3 and this data is loaded from my local. So you can use the data from local also. You can use the data from your data lake also. So any questions from anyone, you can ask them. So now you can unmute yourself. If you have any questions, we can ask. Okay, so in enterprise, Snowflake can be used in the data platform in any of these layers. You can use it for data engineering. You can use it as a in the data lake along with the data lake. You can use it as a data warehouse. You can use for data science. You can use for data driven applications. You can build data driven applications. You can use it for data sharing. You can Snowflake plays a major role in a data platform. Okay, so you can use Snowflake as a data warehouse. You can use it as an integration for data engineering you can use, or data science you can use. So company use it for different purposes. So they combine and use, sometimes I will use cloud for ETL. I use Snowflake as a transformation layer or storage layer. Sometimes I use Snowflake only for storage. So it's about organization, how the architecture they design and what purpose they use. It's depending upon the organization they use Snowflake in any of this lake. It's not that they have Snowflake, they have to use Snowflake in all the layers, right? In a data platform, they have multiple layers. So it's not that they have to use in the ingestion also Snowflake, in the storage layer also Snowflake, in the processing layer also. For everything, they are not going to use Snowflake. So because Snowflake has a cost involved, because it's an enterprise product, there is a cost involved. So to run any Snowflake SQL, you need warehouse. So if you see in my SQL, whatever I did, so if I go to SQL, it ran on top of a warehouse. So you can see the query, whatever I did, a select statement, whatever I did, it ran using a warehouse. So Snowflake needs compute. So you needs a warehouse. Without warehouse, your Snowflake will not work. And that involves cost. Okay, so even though the storage is cheaper here because it's storing on the cloud, the storage is cheaper for Snowflake, but your warehouse is a costly one. So companies use based on their purpose, they use Snowflake or they use ETL tools. Okay, or they combine and use. Sometimes they for ETL tools for some purpose, they use for transformation they use Snowflake, and for storage they use Snowflake, and some of the ETL tools they use Snowflake. Like that for different purpose about the company's architecture, they use Snowflake. Okay, now let us discuss about the point we have seen so far. So as I said before, Snowflake is a cloud-based data platform or a data system designed for data warehouse, analytics, and data collaboration. Okay, so Snowflake is used for in a data platform. It can be used for data warehousing, it can be used for analytics or data collaborations. It runs on AWS, Azure, or GCP. Okay, so it's a cloud-based data warehouse system. You cannot run on premises, you need cloud. It can run on top of AWS, Azure, or GCP. It's fully managed infrastructure. You don't need any infrastructure. It's managed on the cloud. Okay, you don't need to create VMs. You don't need to create storage. You don't need to create databases. It's everything is fully managed by the Snowflake system, by the Snowflake team itself. So you are not going to do. It's a SaaS product. It's a software as a service. Okay, so it's easier to use. It's multi-cloud support. You can run Snowflake on any of the cloud. I can run it on Azure. I can run it on AWS or GCP. And migration also is easier. So I can migrate from one cloud to other cloud. So I can migrate from AWS to Azure or Azure to GCP based on your company's requirement. You can migrate easier. And Snowflake is cloud native data platform. It works only on the cloud and it supports, you can use with Snowflake and write SQL or you can use programming language like Python. Okay, so you can write in Snowflake, you can use SQL or you can use Python. We call it a Snowspark, but the transformation, the lot of logics you can write is the Python. Also, Snowflake is accessible using WI, CLI, JDBC, ODBC. Okay, so using different connections, Snowflake is accessible. So far we used from browser. So Snowflake we used from browser. This browser is called Web UI. So Snowflake Web UI, they call it a Snow site. So this is called Snow site. So using this, you can access Snowflake. You can write SQLs. You can write Python code here. So you can create SQL worksheets. You can create Python worksheets. You can create notebooks. You can create dashboard applications. So you can work on Snow sites. So Web UI, you can use command line interface. Snowflake has a CLI tool. You can write command line interface. JDBC ODBC connector. What is this? So if you are using Python or if you are using Java or .NET, any application, backend applications, or you are using visualization tools like Power BI, Tableau, QuickSight, like a lot of business intelligence tools, right? All these tools use JDBC, ODBC drivers for connecting to Snowflake. Like, so if I'm using Java application, Python applications, I can connect to Snowflake and get the data using this connectors. Okay, this connector helps you to connect to Snowflake and extract data. Okay, so you can use this connections and extract data from Snowflake. Okay, so the advantage of Snowflake. What are the advantage of Snowflake? It's zero maintenance because it's a SaaS product. The maintenance effort is less. So you don't have to worry about infrastructure. You need cloud access. So if you have cloud account, you can create Snowflake. Okay, so it's easier to maintain Snowflake. You don't need to do like infrastructure setup. You don't need to do setting up machines, cluster. So these are the problems faced by data warehouse system in the future, in the past. In the past, companies have problems in maintenance. So data warehouse system maintenance was a bigger problem. So if you are using Snowflake, you don't have to worry about maintenance. So for example, if you are going with Redshift, and Redshift has serverless and dedicated servers. So if you are using dedicated servers, you have to set up the cluster. The maintenance will be a bigger problem. Okay, you have to increase the cluster, you have to reduce the cluster. So when you are using Redshift, dedicated servers, maintenance becomes a bigger problems for organizations. Okay, so in Snowflake, maintenance is very easy. And Snowflake is very fast. Okay, so it's very fast and you can easily scale it up. So you can handle large volume of data in Snowflake. So as I said, we have a sample data. I go to database. In the sample data, I showed TPCH data, SF data. So in the sample data, I showed orders table is 1.5 million. They provide you can see a TPCH, SF1, SF10, SF100 and 1000. So what is this? It's a 10x, 100x and then 1000x. So in 10x, so in SF10, you have the same tables. If you go to orders, you can see 15 million of data. So from this, from the orders table of SF1, it's 10x. Okay, so it's here you see in the SF1, you have 1.5 million of data, whereas here it's one orders table, it's 15 million of data. Whereas if I go to SF100, the orders table, it's 150 million of data. It's 100x, right? And if you go to 1000x, it's 1.5 billion of data. So it's 48.6 GB of data. So you can see how big the data is. So I can easily use this data for doing some performance testing. I can work on queries here. And for analysis, I can use this data. Okay, so let me quickly go to my worksheet. So the worksheet which we used. So if I'm going to run a query here, what I will do, I'll go to this big data set. So we can see this sample data. So we can see this data is here. So this data, I am going to run a query. So Snowflake sample data dot tpch 1000 dot orders. So I want to see count. So let us see the count of this total record. So let us see how much time it takes. So this is a very big data set. I'm going to run a query in Snowflake. So you can see how fast count worked. Okay, so I did a count and the count was very faster. You can see it's like 150, 1.5 billion of data. The count query was faster because it was fetching these statistics here. So it was very faster. Whereas, so I'm taking 10 records. So I'm fetching few records. Again, it is very faster because you are taking sample of data. Like that, if I run any queries in the Snowflake is going to be very faster because of they have inbuilt micro partitioning and they have a micro partitioning where parallelization is inbuilt. So they are going to fetch you the data faster. So Snowflake provides you faster access to data. For large amount of data, you can fetch it faster using Snowflake. Okay, and Snowflake also provide you can access structured data, semi-structured data like JSON data, XML data, Avro data. You can access structured data also, semi-structured data. And you can have multiple users. You can create access to multiple users here. In Snowflake, you can see users and roles. So I can create multiple users and provide access to tables and give them permissions. So multiple users can access Snowflake. And everything is done in SQL. So Snowflake supports all the SQL syntax here, and you are going to do everything as a SQL. Okay, so these are the features of Snowflake and data sharing. So data sharing. So I have data, I have created data, and that data I want to share with another person. So I can easily do with Snowflake because Snowflake is running on the web. It's on the cloud. So you can share data. I can share particular table or share particular schema or particular columns. I can do multiple, this we call it as governance. Data sharing is easier with Snowflake. So I can share one table or entire schema or few columns. For granular level of detail, I can share easily with Snowflake. Because Snowflake, it's running on the cloud and it's on the web. So it's easier to share your data. Okay, these are the features of Snowflake. And let us see the last one. So in Snowflake, you can use it as a data warehouse. So you can run your SQL analytical systems. You can run SQL and use it as a data warehouse. So you can combine with your data lake to processing with your data lake. Okay, so you can store structured data, semi-structured data, and you can combine with your data lake and use Snowflake. And you can use Snowflake integrated with your ETL. You can do ELT, you can do ETL both. So in Snowflake, you can build ETL pipelines. You can perform ETL also. You can do ELT also. Okay, and you can use it for streaming. You can use it for batch processing. And data sharing is easier. Without duplicating the data, you can share the data with multiple teams. And in Snowflake, you can do ML pipelines using Snowspark and UDFs. Okay, so you can easily build machine learning pipelines in Snowflake. And you can use it for streaming real-time analytics. Also, like using Kafka, Kinesis, streaming pipeline also, you can use Snowflake. And governance is easier. Building security, compliance, auditing future is very easier with Snowflake because it's very easier to use it from UI. So governance is easier in Snowflake. Okay. So any questions from anyone? Now you can ask all your questions.
So
So any
we don't need to manage the or configure anything on the AWS account that Snowflake uses.
so we need to do some configuration. For example, right? Like when I accessed my AWS S3 bucket, I gave some credentials, right? You see,
Mhm.
when I created my stage, I gave some credentials. So this credentials I gave directly. Instead of that, you can use different way. There is a AWS integration, which you can use it for integrating your another bucket. So you will integrate with your account with another AWS account, so you can access the bucket easily.
Okay.
Okay, why we are doing it? Because permission is very important, right? So if I'm able to access any other bucket, right, any other person's bucket, then what will happen is data privacy will be a problem, right? So that is why credentials are important. Authentication is very important. So this is an authentication. So without you this bucket, this bucket, even you can use it, but you need to have this credentials. If you don't have the credentials, you cannot access it. So that becomes authentication. So for accessing this bucket, you need to have credentials. Using that only you can access it.
Thank you.
Hello, Wayne.
Yeah.
You said the Snowflake will play different parts in the sense in the extraction, transformation, and storage. Now
Yeah.
we extracted the data, CSV data, into table, right? That draw
Yeah.
schema has been created. So now the Snowflake plays a role of extraction in the sense ingestion.
Yeah. So we have extracted the raw data. So let us say that that is why when I created the schema, if you see here, I created a raw schema. Okay, I meaning that these are raw tables, raw data. I cannot use this consumers, I cannot give access to consumers. So this demo schema, I'm saying this is a process tables. And this is a raw schema. So I have to transform it, process this data, then store it into different table, then only consumers can use it. Okay,
Okay,
so in Snowflake itself, you create multiple tables. You maintain different type of schemas. So you maintain raw table separately and process table separately.
okay. Now Snowflake played the role of ingestion and also the storage.
Yeah, correct.
Okay. So can we say this demo schema like it also play add the transformation layer?
You can create multiple schemas, right? So I can create here processed, aggregated schema, everything. So here you can do transformation logic also. You can your database is nothing but a logical unit, right? So inside the database you can have multiple schema, and I can create multiple tables and store different kind of data. Okay, so it can be a raw data, it can be a processed data, but how you are creating is important. So I can create one database, one schema, put all my data inside. Okay, that also I can do it. Or I can create multiple database. For each purpose, I can use different database. That also I can do it. So for example, let me tell you. So I have Snowflake. Within Snowflake, I can create one database. Let us say sales, one database. Within that database, I'm creating one schema. So let us say that. So this is database name. Schema, and I can create raw sales data, processed sales data, aggregated sales data. So all these things are tables. So like this I can create, or I can create. So I'm creating 3 different schema. Okay, so like this I can implement. So here I'm creating different schemas. So I am giving access here, right? So the permission, I can give access to this schema, aggregated schema, process schema. So your access level, governance will become easier. So if you're going to do like this, your governance will become easier. If I'm going to do this, I can give table level access, governance is going to become difficult. So that is how you design the tables. In Snowflake, you can do like this also. You can do like this also. Or other ways, I can create database separately and create tables separately. So the governance will become easier when you are going to do this. When you are going to create a different type of schemas or database, the logical grouping of data, that helps you to do governance better. So if I'm going to give access to data science team, I can give access to all the schema. If I'm going to give access to analytics team, I can give only the aggregation schema access. So that is how all the tables within aggregated schema, right? So let me have, I have customer, have product. So I have multiple tables here. So I don't have to give individual table level access. I can give access to this schema alone. So they can access all the tables. So your governance will become easier. How do you design the system? When you design the system, if you are going to design your system easier or make it very simple enough, then your governance will become easier. Okay.
Okay. Yeah.
Okay. Any questions from anyone?
So one question I have is, if you are introducing Snowflake as the new data warehouse versus, let's say, replacing an existing one, is there a difference in how it's implemented in
So
both the scenarios?
if you are going migration, right? You're asking existing warehouse, you are replacing with Snowflake.
Yeah.
How you are going to
Mhm.
implement.
Yeah.
So the migration, you will do it first. That means you will take the entire data, move it to Snowflake, and then slowly you will do incremental processing. That means whenever data comes, that data will be incrementally updated to the Snowflake. Then slowly replace the entire Snowflake with your current data warehouses. That is how you do migration. Okay, that means what you do, you take the entire data, do a full load, and bring the data into Snowflake environment. The entire database, tables, everything, you bring it. Then we are not going to straight away replace change the existing system, right? So you will do comparison of like a database and tables. You'll see all the data are matching. Till that, you will do incremental loading. That means changes will be loaded into Snowflake, and you will do comparison, day by day comparison. You'll do it. Then after that, everything is fine. You will replace the existing system with Snowflake.
Okay.
That is how we
And
do
then,
it.
sure, thank you. And the last question I have is, I mean, in when creating the AWS account, Snowflake account, it showed whether Azure or AWS or GCP, right? But nowadays,
Yeah.
with multi-cloud, right? Well, so how is that? Is it limiting, or is it, how are people adopting exam here, right here? So multi-cloud is the more common nowadays. So what's
Multi-cloud means they support AWS, Azure, GCP. Okay.
Mhm.
But it's going to run on only one cloud. It's not that dynamically it's going to run on all the clouds, right? So even though they support multi-clouds here, so that means why they say multi-cloud means replication is easier, backup is easier, migration is easier when they are doing a multi-cloud support. So,
Mhm.
but always they are going to run it on one cloud only. Okay, so when you first use the Snowflake here, they are going to use only one cloud. They'll be using only one cloud. So you have to give your AWS account or Azure account. They will install and run it on only one account. And if you want to migrate, you can go to Azure easily or GCP directly. You cannot have you cannot have everything, right? You cannot give your all your cloud account and ask Snowflake to run it on all the account. You cannot do that.
Right. Okay. Thank you.
Okay, so Snowflake is used across different cloud. That means I am an enterprise. I'm using AWS cloud. All my data are there in AWS cloud. So I can install, like I can integrate easily Snowflake into my AWS cloud and start using in AWS cloud. And suddenly we are migrating into Azure. Think that we were migrating all our application to Azure because of licensing or because of cheaper discounts. So we are migrating to Azure. So I can easily migrate into my Snowflake environment. I can easily migrate into Azure because it supports cross cloud replication. That means you can easily create a database. You can create a new account in Azure and you can replicate your database from AWS to Azure. So replication will happen immediately. So your data will be moved from AWS to Azure and you can start using from Azure. That means the backup is easy. Migrating from one cloud to other cloud is easy. That is why Snowflake supports multi-cloud, but it's going to run it on only one platform. So it's going to run on only one cloud. So when you are going for trial, it will ask for you to select Azure or AWS. So you can select for one and then start. That is how you can start. Okay, fine. Any questions from anyone?
So so complete the data storage and processing, everything in cloud, right? Nothing is in the local.
Yeah, we are not going to use local because we have data compliance, data security issues. So we cannot store the data in local. And Snowflake internally is storing into our cloud only. So Snowflake uses AWS cloud or Azure cloud, my account. That means my organization account. So Snowflake is storing the data into organization cloud account. So it is under the security and compliance policy. So Snowflake's data is secured. But whereas if you are putting the data into your local, then you will have complaints. So you cannot have the data in local. So it should be there in a company provided server or company provided machines. You can have the data.
Yeah, processing also in the cloud, right? Not
Yeah,
just
processing
data
on the
store.
cloud. Yeah, and why
Processing
is
also.
the data is huge? We are going to have large amount of data. So processing has to be done in multiple machines or one machine. So that is why it's going to use cloud VMs to process your data.
Okay. Say for example, if I opt Azure as my storage, so everything completely in Azure, or the Snowflake intern maintain the metadata in AWS. Even I opt Azure.
It's completely into Azure. So metadata will be there
Metadata.
in Azure. Yeah, metadata will be in Azure.
No, the sample data what you seen, that also in Azure, right? That
Yeah,
also
it will be Azure. So everything is running on Azure environment.
Because so because the sample data, they're not allow us to modify, right? So it is simply we can use the data. That's what you mentioned.
Yeah, so if you see here, this account detail is my organization account. Okay, so in that organization account, if I have access, then only I can preview the data also. If I don't have access, I cannot preview the data also. Okay, so access is given to users for table view or any kind of view. They should have privilege to access the data. If they don't have access, they cannot view the data itself. They cannot see the sample data also.
One last question, Sarina. So what about the streaming? Snowflake supporting the streaming data processing?
Yeah. So the projects we are going to do, the second project is streaming project, right? Where we are going to use a streaming pipeline. So Snowflake has a streams and tasks, which is easier to use. And for streaming, live data, you can process it in faster way. You can build a streaming pipeline. We are going to write SQL there and build a ETL transformation, everything on the streaming pipeline. So data coming in from Kinesis are coming from Kafka, produced from IoT systems, produced from servers. All the data you can process it immediately next 5 minutes, and you can view the data in dashboards that you can implement using Snowflake. Okay, streaming pipeline.
We are going.
Yeah, we are going to see that in a second project.
Okay. Something called I was getting email from the Snowflake. Something called Cortex. What is that?
Cortex is a like AI system where you can build AI models. In Snowflake, Cortex is a completely AI system, AI solutions for integrating your machine learning model. And using that, you can use your data, run your queries, do generative AI or machine learning models. You can use it in Snowflake. It's a future which is for enterprise future. In the trial also you will have only basic future, but if in enterprise you will have a lot of features there.
But are we going to see that as well, or not?
I will show a little bit on ML and AI use case, how it is used. I will tell you the scenario, but we are not going to cover deeper on that. So with the data engineering, how ML integration happens, or data science, how use cases are being done, that I will explain it in the scenarios, and I'll show you a Python like ML integration model, how it is done. That can be Cortex also, how Cortex implementation is done, or ML model is implemented. I'll show that in a demo session. I'll show that.
Okay.
Well, like as I discussed before, like about the streaming process, the Kinesis and the
Yeah.
Kafka. So they will be the data sources for the Snowflake.
Yeah. So as I said before, the ingestion part, it can be from batch processing system, bulk load. You are going to do bulk load also. You are going to do streaming also. So ingestion, Kafka is Kinesis are one of the ingestion ways where you are bringing data into Snowflake.
Okay. Is there any tool needed between Kafka and Snowflake during this ingestion, or directly Snowflake will play the part?
For Kinesis, we will use Kinesis Firehouse. With Kinesis Firehouse is again AWS service. You will use that for ingestion. Okay, and for Kafka, we will use Python. Using Python, we will ingest the data into Snowflake.
Okay.
Okay, so you can see here. So in the ingestion process, there can be different ways. You can see 6 types of common. These are the common ways of ingestion can be happening. So it can be data source can be in a CSV files or JSON files, or it can be database. It can be on-premises or cloud database. That is one of the source. And streaming source, it can be Kafka or Kinesis. Data is coming and we are ingesting through Snowpipe. So you are using Snowpipe. It's a continuous ingestion of data. So it's a continuous streaming of data. We are using Snowpipe and ingesting the data. And it can be from SaaS product. It can be from different data sources or data sharing. So data can come through all the sources. All this thing are ingestion, different type of ingestion techniques. So we will cover all this thing. You will see how to use copy command, how to use on-premises database, streaming, SaaS products, data sharing, all this thing we'll see.
Okay.
Yeah, I will. So we are using the test bucket to load the data in the Snowflake, right? So that the data where it will store exactly that files. So it will directly fetch the data from S3 bucket and will process in Snowflake, or
Yeah. So here, if you see, I showed 2 accounts, right? So let me show it. So if you see here, this I have Snowflake running. This is my trial version. This is trial Snowflake. And this AWS account, I don't have access. Okay, this is provided by Snowflake itself, this AWS account. And they are storing when I create tables, when I store it into tables. So we created a table called menu. We created a table called sales. So all these tables are created here. So let us say tables are created here. This table, the data stored here are stored in S3. So the data are stored in S3 in this AWS account. But we cannot access this data or see how they are storing it. This is a proprietary, this bucket is a proprietary bucket belonging to a Snowflake. We cannot access this bucket and we cannot see the data within that. Okay, the external bucket. So this external bucket, we can access it. We can see the data because these buckets are belonging to us, and this data, we can see the data, what format you are storing, we can see. But this bucket where Snowflake internally is managing it. These are managed by Snowflake, these buckets. So they create the tables, they store the data. So we cannot see this bucket, we cannot access the data. It's internally managed by Snowflake. Even though this account is our AWS account, in organization, this account belongs to our account, but we cannot see what they are doing it inside the bucket. We can see the bucket, they are using some bucket, and they are doing something within the bucket, but we cannot see the content. We cannot access the content within the bucket. Manually, we cannot access. Only by using tables, we can access the content. Okay, is it clear?
Yeah. Thank you.
So this buckets are external. These are external accounts. External storage account. So this can be AWS. This can be external storage. Can be AWS or Azure or Google Cloud. This becomes internal storage account. So this is the internal storage account. So this internal storage, we cannot access it. This becomes proprietary of Snowflake. They maintain and manage it.
So through the tables only we can access that.
Yeah,
one,
through
right?
tables only you can access it.
Okay. And you have given the table structure, right? Menu table structure. So how we will get to know like what are the columns in this without looking into that one?
So we will see the data and we will define we know the data. So we define the schema, right? So so this internal storage, this internal bucket, it's a for storing only. Okay, so our external bucket data will always come to external bucket only. Data will not come to your internal storage. This storage will not be used by any other teams. Okay, this bucket, it's accessed only by Snowflake, and the data will always come to external storage. So from that only, we will able to access this external storage. We can see the CSV data or JSON data schema of that. So we will create the tables and we will create the tables and then store the data into the tables. So internal storage, it's created by only by Snowflake and they are managing it. So other teams or other persons will not directly store the data into this bucket. Okay.
Yes.
Okay, any questions from anyone? So if we don't have questions, we will stop it for today and then we will connect next week. So by next week, I want everyone to create your trial version of Snowflake account and your AWS account. Okay, so you can start practicing. So you can start working on things, right? So that is why I showed a simple demo here where I showed creating database, creating schema, and then working on your AWS account or your Azure account. So you need to create. So next week, we are going to start with cloud integration. So that means we'll have a cloud account. With your cloud account, we will put the data into cloud and access the data. Or we will use copy command and then extract the data and load it to Snowflake. So we are going to start from next week onwards. So if you have your cloud account, it will be easier for you to work. So you can create your trial version of Snowflake account and then AWS account, trial account, you can create it by next week. Okay, fine. So if any questions from anyone? Okay, we will stop it for today and then we'll connect next Saturday. Thanks, everyone.
Yeah. Thank you.
Thanks, everyone. Bye.
Thank you.